Hello and welcome to another Hidden Gem screencast. My name is Arden Thomas. I'm the Cincom Smalltalk product manager. Hidden Gems is all about showing you features of the product that may be useful but may not be obvious. This month's Hidden Gem is about parsing. Parsing is an important part of computer science, and in fact it's the beginning step of compiling source code, but there's a lot more to it as well. Parsing transforms a syntax into another format for an intended purpose. So parsing and parsing techniques is a very large topic, and we're not going to delve into too many details. You'll see terms like LALR, look ahead, left, right, PEG, PackRat, parser generator frameworks. There's a lot you can explore, and I encourage you to do so. We're going to show something brief, and hopefully it might be useful to you. So often a needed parser will already exist, so why would you want to write one? Well, you might need a custom variation on a parser, or no parser exists for your requirement. You just want to learn more about it, or maybe you want to create and support a domain-specific language, and Smalltalk is great for creating parsers and domain-specific languages. For an example, we're going to examine and create a simple parser for the Json syntax, that's JavaScript object notation. And the first step you want to do is find a syntax definition. By the way, there are already JSON parsers, and we'll talk about those. We'll talk about those in another episode, but we're going to use this as an example to show you how to create your own custom parser. So in the workspace up above, you can go to json.org to find the definition for the JSON syntax. You can find it in forms like BNF, which is a Bacchus-Nauer format. John Bacchus of the Bacchus-Nauer format was a computer scientist who created Fortran and also a functional language called FP, which I experimented with before discovering Smalltalk. Pretty neat language and ideas behind it. A practical format you can often find is called a railroad diagram for pretty obvious reasons. So let's take a look at one for JSON. We're going to concentrate just on a few things. Here is a JSON object. This tells me a JSON object is an open bracket followed by a string, a colon, and a value. And then you can close it, that's your complete object one, or you can continue by having a comma and then another string value pair separated by the colon. That is the notation. Also, here is for a JSON array, very similar, an open bracket, value, close bracket. You could have an empty bracket by following this path, or you can have a bracket, a JSON value, and many JSON values separated by a comma, and finally a close bracket. So both of these have a JSON value. What does the JSON value look like? Well, here's what it looks like. A JSON value can be a string, number, object, array, true, false, or null. And indeed, each of these has its own railroad diagram specifying exactly what is legal and what is not for this syntax. We're not going to delve into too many details there, but we'll concentrate on this at a higher level. So we have the syntax. You also want to try to find some examples that you can use to test parse, and then begin building and iteratively testing and checking out your work and enhancing it. So what I'm going to show you here now is an example of a JSON array syntax. And we're going to parse that. I've built this already. We're going to walk through it and show you some of that. So the value, a JSON value, is the high-level thing that will be approaching first, because a value can be an object, an array, or any of these lower level components like a number, for example. So let's try this out. I'm going to debug this. self-test array, self-parse the array. We're going to create a new instance of our JSON parser and parse it. The first thing we do is create a read stream and store that in the object. So we'll do that. Now parse value. What you'll often do in a parser is depending on how it's handled in the syntax, is skip white space. So let's see what this looks like. Next is white space, while true, next. So we consume that as we see if it's white space. Let's take a look at this. So we peek into the stream. If it's a space, a carriage return, or a tab, we return true. And in this case we are not. So what it will do, it will consume any white space, and then you're ready to begin with an actual character. Are we done? If true, we return. Are we in open bracket? If so, parse the object. Are we in an open array bracket? If so, we'll parse the array. So we are indeed an array, so it should go into this, which it does. Parse array. So parse array, skip white space. Let's do that. Is it open? If true, we consume that open bracket, and we do. Now I'm creating a new collection to store the array values, and then we're going to parse value. Let's take a look at what that looks like. Skip white space. Is it open bracket? Is it an object or an array? No. Okay, it is probably then. For the value, you have a quote, an open quote. We'll consume the quote. We'll go up. The value is up to the close quote. So let's take a look at what our value is, and our value is Sunday, and we return the value. We're going to add that value to the collection. So here we're transforming this from the JSON syntax into an array of the values specified by the JSON syntax, so we have a form that we can use it in. So while we're not at close array, if the next thing is a comma, we're going to consume that comma, and then we're going to parse the value. And if we look at our collection, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, we're close array, and we pop it as an array. So actually, let's even go back, and I'm going to inspect the results of this. And in fact, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So next time we'll go into a little more detail about this. And if you'd like the source code to this to follow along, please send me an email at athomas@cincom.com. Until next time, happy small talking. Thank you.